Okay, welcome back. This is Mr. Hassan's Maths channel, and this is question number 11 from the June 2013 R paper from Core Mathematics C1, which now corresponds to the new P1 papers. And this is a question where you have a straight line, y equals x plus 2, and some curve, x squared plus 4y squared minus 2x equals 35, these two equations, and they intersect in two places, A and B, and we need to find those points of intersection. Okay, we need to find the coordinates of A and B, the points at which they intersect, and we need to solve these two equations simultaneously in order to do so. That's how you find how two lines or two curves or a line and a curve intersect. You solve the equations simultaneously. So in order to do that here, what we're going to do is we're going to take the equation of the line, which is y equals x plus 2, and the equation of the curve, which is x squared plus 4y squared minus 2x equals 35, and we're going to try to figure out where they intersect. So to solve such a pair of equations simultaneously, we have to use substitution. So we have to take the linear equation, so we focus on the linear equation first, and we try to make the subject of the equation the letter which is going to give us the easiest time, in trying to solve. So first thing we look at is the coefficients of y and x. If the coefficients are such that we don't end up with a fraction, that's the best thing to do, because then we'll have an easier time in substituting something which is not in fraction form. So both of x and y have coefficients of 1. So if I make x a subject, I'll get x equals y minus 2. Y is a subject, y equals x plus 2. Both of them are perfectly fine. Then I look at what I have to substitute them into, which is the other equation. Now here I see two x terms, x squared and x, and one y term. So it's probably easier for me to use it the way it is. So I only have to substitute one time into this equation. I don't have to substitute in two different places. That's probably the easiest thing to do. So that's what I'm going to do. I'm going to replace the y with x plus 2. So instead of having 4y squared, I'll have 4 times x plus 2 squared. So I have x squared plus 4, instead of y, replaced by x plus 2. So that's going to be y squared, so x plus 2 squared. Take away 2x equals 35. Now I can solve this equation. This is an equation with only x in it, and I'm able to solve it. It looks like it's going to end up as a quadratic. So anyway, let's expand the brackets and see what happens. So you have x squared plus 4 times. Now I'm going to square this bracket. That's going to give me x squared plus 4x plus 4, take away 2x equals 35. A little point of caution, x plus 2 squared is not x squared plus 4, which many students, they make that error. It means x plus 2 multiplied by itself. That's what it means. So you're going to have x squared plus 2x plus another 2x, which is plus 4x plus 4. Now a squared bracket can also be, you can use the pattern for squaring square brackets, which will help make it quicker, where you square the first term and you square the last term, but there's always a middle term, which is the product of the two terms in the bracket doubled. So x times 2, 2x doubled, 4x. That's a quick way of expanding the bracket, but don't ever write this. This is a very common error, and it messes up your whole question, of course. So now we've got x squared plus, now expand this bracket, 4x squared plus 16x plus 16 minus 2x, and I'll bring the 35, subtract 35 on both sides, so I've got equals 0, because I see it's going to be a quadratic equation, so we'll use the zero product property. So I'll make everything equal to 0. So I have 5x squared, 16x minus 2x is plus 14x, and 16 minus 35, that looks like it's negative 19. That's right, 16 minus 35. Let me just confirm that. 16 minus 35, just to make sure in case I make a mistake. Negative 19, that's right. In fact, this was a paper in the old days, C1 papers, you weren't supposed to use calculators in them actually. I just did that to check, but that's something in the days before 2019, the C1 paper was a non-calculator paper, right? So all this is supposed to do this in your head basically. So now we got this quadratic which we have to solve. So you see, without a calculator, how would you solve this? Well, it's not as difficult as it seems. It looks like it's pretty difficult, but it's not. So basically, we've got to find, we've got to, factorize this. So here, splitting the middle term would be a sensible thing to do. I split the middle term in my own little fashion, which is by using this grid. Okay, and I basically write on the top left the x squared term, on the bottom right the constant term. If I multiply those two numbers together, I should get the same product as multiplying these two numbers together, and the sum has to be 14. So I've got to find two numbers whose sum is 14x and their product is 19 times 5. So 19 times 5, that's like 19 times 5 is 50 plus 45, which is 95. So the product is negative 95x squared. So I've got to find two numbers. When I multiply them together, I get negative 95, and when I add them together, I get plus 14. So I know one has to be a positive number and one has to be a negative number because their product is negative. And let's see. Now, if I have to multiply them together to get 95, then I'm pretty sure one of them has to end in a 5. Okay, that kind of makes sense. When you multiply numbers together and you have 5 as the last digit, then normally you're multiplying by 5. So let me see what happens if I divide 95 by 5. So 95 divided by 5 gives me what? 5 goes into 9, 1 time remainder 4, 5 goes into 45, 19, 19 times 5, that's right, so that's going to give me 14. So it's the same two numbers, 19 and 5. Okay, so you're going to have plus 19x and minus 5x. Okay, so that worked out okay. It was the same two numbers basically. So now if I take out the common factor from these two terms, it's going to be 5x. And from these two, well, 5x times x is 5x squared. 5x times minus 1 is 5x. And x times 19 is 19x. So I end up with x minus 1 times 5x plus 19 equals 0. So those are my two factors. So I've now factorized this. And we can see that either x minus 1 is 0 or 5x plus 19 equals 0. So either x equals 1 or x equals negative 19 over 5. So we found the x coordinates of the 2 points. So obviously the x coordinate of A is 1 and the x coordinate of B is minus 19 over 5. All right, so we can see at A, x equals 1, and we know the equation is y equals x plus 2, x plus 2. So therefore we can say y is equal to 2 plus 1, which is equal to 3. So the coordinates of A are going to be 1, 3. So that's the coordinates of A. And at B, x equals negative 19 over 5. So y is equal to negative 19 over 5 plus 5 over 5 basically. Okay, 1 is like 5 over 5. So minus 19, plus 10 over 5, plus 10 over 5, not 1 over 5 because it's x plus 2. It's x plus 2. So plus 10 over 5, which gives you negative 9 over 5. Okay, so that's the coordinates of B. The x coordinate is negative 19 over 5, and the y coordinate is 9 over 5. So there we have the answer to question A, 11A. We found the coordinates of A and B. How did I know A was the one which has the positive coordinates? Because in the diagram, A is shown up here and B shown up here, down there. So A must be where x is 1 and B where x is negative 19 over 5. So that's the answer for part A. All right, now we're going to go on to part B. Now we have the coordinates of A, so let me take them over to the other side. Okay, so now here we have part B. It says find the distance AB in the form r root 2, where r is a rational number. So we know the coordinates of A are 1, 3, and the coordinates of B are negative 19 over 5 and negative 9 over 5. Hold on, what did I write there? Let me just make sure. Yeah, that's negative 9 over 5. Take that back from before. It's negative 9 over 5. Okay, so some of you would have probably already written in the comments, oh, you wrote the coordinates of B wrong. Well, I've gone back and corrected it, thankfully. Okay, so good. So there's negative 9 over 5. Now, what we can do is we want to find the distance AB. So the distance from A to B is equal to, basically, using Pythagoras' theorem, the change in x squared plus the change in y squared. So we're going to have here the square root of, we're going to have 1 minus 19, which is 1 plus 19 over 5 squared, plus I'm going to have 3 minus 9 over 5, so 3 plus 9 over 5 squared. Okay, so remember, this used to be done without a calculator. Now you can use calculator, so it's not a big deal, but I'm going to just do this in the old way. Okay, so this is going to be 5 over 5 plus 19 over 5, which is going to be 24 over 5 all squared. Plus, this is going to be 3, which is this is going to be 15 over 5 plus 9 over 5, which is also 24 over 5 all squared. Okay, so we got something quite interesting here. Okay, I guess this is why this is you can do this without a calculator, because what you got now is you got the square root of, and you got 2 times 24 over 5 all squared. Okay, 2 times 24 over 5 all squared. So if you were to find the square root of this, you would have 24 over 5 times root 2. Okay, so that doesn't require you to do any long calculations here, because you can see this can be done without a calculator, the way the numbers worked out. It looks like it's going to be complicated when you see it like this, but because they both ended up being the same thing, you got 2 of them. And then, 2 times the square of 24 over 5. Well, the square root of the square of 24 over 5 is 24 over 5 and times root 2, because they want it in exact form, in this form here, where r is a rational number, so we can see r here is equal to 24 over 5. So it looked complicated, but when we saw this, it made it easy. In these days, you wouldn't have to worry too much about that, because you will get this, just put this in your calculator to get the answer. So there was a slightly different skill required in the old days. A lot of students, I think, would have expanded from here and got all flustered because the numbers would become so big that they wouldn't know what to do. So there's a little trick here. These little tricks that I guess nowadays with calculator papers, you don't really appreciate those tricks now. But that's a little trick of answering that question. If you were to do it nowadays, you would just stick this all in your calculator and you'd get your answer, and that would be a good way for you to check to make sure your answer is correct. You would say, okay, the square root of 1 plus 19. In the old days, you couldn't even take a calculator with you in the exam for this paper. It was not allowed to even take one in the exam, even to check. But nowadays, at least you can check. 9 over 5 all squared, and that gives you 24 over 5 times root 2, exactly what we found over here. So there's the answer for that question, and that's the end of that question, end of the paper. Thank you for watching, and if you want other questions which are related to this topic of simultaneous equations and quadratics, you'll find them in the playlist that should appear somewhere over here. In this playlist that should appear in this area here will be other questions from this particular paper of June 2013R paper from C1. Once I'm requested to answer some more questions from there, you'll find them there, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.